Evening folks, and welcome back to the WTF for another video. We're not wasting any time and we're cracking on with the next project, which is this thing here, a Collins 618T. Now I'm not going to open all this up and show you. I'm going to do another video on this. This video is actually really sort of concentrating on the power supply for this rig. This radio, which like I said I'm going to talk about a bit more later, requires 28 volts or around about 26, 27 volts, and it also requires 115 volts, 400 hertz. The reason for that is that this is an ex-aircraft or aviation radio transceiver, and obviously we've got to supply those voltages. Now the 26 volts or 27 volts needs to be about 30 amps. So in order to get that, it's a bit of a difficult thing to get hold of. You know, certainly most of the amateur radio power supplies that you can get are generally around about 13 volts or 13.2 volts, thereabouts, and they don't really supply, well, they will go up to about 30 amps, but obviously we need 26 volts, 27 volts for this. So trying to get a power supply for that was going to be a little bit of potentially a little bit of a challenge. However, we have got these two things which have come to our rescue. Now these are switch mode power supplies from some sort of computer server. They are the DPS1200SP, and these are 12 volt units. I think they're rated at something ridiculous. I'm getting my glasses on. I think they're about, let's see, so with 240 volts input, 12 volts at 100 amps, so not bad, hence they're called 1200, DPS 1200 watts. So anyway, we've got two of these, and my plan is to put them in series. Now there's a couple of things that I've found out about these things. First of all, you can put them in series and you can put them in parallel. The voltages out of these are about 12 volts, and there is a bit of, like most switch mode power supplies, there's a little potentiometer inside where you can adjust it and get a few more volts. Now from what I've found out, and I will show you in the video, that there's not much leeway in terms of voltage out of these. They'll give you 12 volts plus or minus, probably not even the best part of a volt. So we're going to have to do some sort of trick to try and get these to produce something in the order of about 13.5, 13.6 volts, something like that. And we're going to have to do a trick to be able to wire them in series. Now the problem is with these, as I discovered, and we'll see in the video, it's not quite as straightforward as simply wiring up the connections in series like a battery. There are some modifications you have to do in order to make, to wire these power supplies in series. So anyhow, what we'll do is we'll show you how I got on with these, which is going to be the first step in getting this beast of a radio up and running. I've got a couple of these DPS1200SP server switch mode power supplies on the bench at the moment, and I've just they literally arrived in the post actually not too long ago, so I'm just sort of seeing if they work, and I'm going to try and increase the output voltage. Now there's a few YouTube videos on how to do this. You have to bear in mind that there's two different variations of these switch mode power supplies. There's an FP and there's an SP, and there is some slight differences. I think the FP, the negative, is grounded. I'm about to test the SP. So far there doesn't appear to be a direct connection on the negative of the SP to ground, so that might be an encouraging thing if we want to put two of these in series. So let's let's just turn it on and see what happens before we start messing with it. So that's before any adjustment. I've got 12.29 volts coming out of it, and I believe the right hand of those, the right hand potentiometer is the one that adjusts the voltage. So I'm going to give that a quick tweak with my screwdriver and see what happens. It is very small. I might have to get a smaller screwdriver, I think, because this one's pretty small and it's not doing anything. So give me a moment and I'll see if I can find a slightly better screwdriver. So it looks like it's actually the left hand potentiometer that actually adjusts the voltage output, but it is the amount you can get out of it is not very good. I'm just trying to adjust it. There we go. So it goes from 12.2, and then the next thing is you keep turning, it goes to 12.5, and you can tweak it. So the maximum you can get out of this is 12.55. So I might have to do the resistor modification possibly if I want to get a few more volts out of it. So that's something I'm going to have to look into, I think. So folks, I've done the modification on this to get about 14 volts out of it. I need 28 volts for the 618T. And this modification, if anybody's interested, you can actually find out more about it. There's a couple of YouTubers who have done this modification, and I think the most helpful is probably Mr. BBI, who sort of builds amplifiers and things like that, and has done quite a bit of work with the DPS or 1200. So there's two resistors you have to put in. The first one is a 20k. Now I'll see if I can zoom in on this. Hopefully, maybe not. It might be a bit blurred. Let's see if we can adjust the zoom a little bit. I think that's about as far as I can get. So that's a 20k, and if you search for, let's see if I can get it into focus. Those two, so you're looking for the two pots, and if you come across, there's two slightly larger SMD capacitors, I think they are, or would they be resistors? Difficult to tell. I think they are probably capacitors because they're brown. And then you come across, and then one leg of that resistor, there's a slightly larger resistor or component, I should say. It's difficult to tell. I think it's probably a capacitor because again it's brown. And you then, I can zoom in a little bit on there. No, it's not letting me. As close as I can get with this camera. And then the other leg goes into the first hole. There's a row of holes on the left hand side of the PCB, and the first one is where that resistor goes. The other resistor, I need to turn the board over, so I'll show you that in a minute. Just give me a moment. The other resistor is a 51k resistor, and apparently this is a modification that's required to alter the crow bar threshold of the protection circuitry. 51k, and it goes from the same point as the other resistor on the end of the it's going out of focus a little bit, on the end of that row of holes. That hole goes all the way through, so you can just poke your first resistor through, and you solder it one end on there, and then you're looking for, there's a sizable IC, integrated circuit, and you solder the other end of that resistor onto the second pin as you're looking down on top of it, and that's all you need to do. And as I said, if you want more information on this, Mr. BBI's got a whole load of I think he's the authority on modifying these power supplies to get more volts out of them. So I've got to do the same now with the other one I've got, and then hopefully we will try and put them in series to get the required voltages. I'll just demonstrate this a minute. Let me just put this off the meter. Just move the meter across. So just remember, previously we could only get 12 volts out of this, so I'll just turn it on. There we go, 14.27. Now I suspect that may well drop a little bit. Having made the resistor alterations in order to adjust the voltage on these power supplies, I did try to wire them in series, but unfortunately it doesn't work. So I believe that you do have to float the power supplies and isolate the boards from ground, which is the common method of doing this in order to put them in series. Just to let you know what happened when I did put them in series, although I got the correct voltage, I was drawing too much current between my crock clip, and there's obviously no isolation in the negative sides. Anyhow, I'm just going to show you this. I mean, there's hundreds of videos on YouTube about this, but I thought if anybody hasn't seen them, I'll show you how it's done. So essentially on these power supplies, there's 3 screws that hold the PCB in, and you can see them there. 1, 2, 3. The third one's over there. And what you have to do is take the back off it like I previously did, and you've got to undo these screws. There's one there, and the other one is underneath there, right at the bottom, underneath where the mains power comes in. And then once you've removed the screws, in fact once you've removed the top part, this mains plug literally is only stuck on, so you just pull it out. You unscrew the grounding lead there, which goes onto that tab, and then you unscrew the fan guard, which I've got over there sitting on my receiver, and again the fan is just stuck on, so it just pulls out, and then there's an LED there which you have to remove as well. And then after that you just simply unscrew the whole lot, which is what I'm going to do. So once you've removed those screws, you should be left with the PCB on its own. You can see that. And what we have here is the main chassis, and you can see the 3 screws, 1, 2, and the other one's there. So if you take a look at this in more detail, so you have a look, you can see the profile there. You've got effectively, those are screw retainers with built-in spacers. So zoom in on that. We've basically got to remove or drill out that retaining nut, or whatever you want to call it, with the spacer. And then the easiest thing is to put the PCB back with some plastic screws, because we've got to isolate, effectively we've got to isolate the PCB from the chassis. So let's get on and do that. These actually drill out quite easily. I think they're made of something like possibly aluminium, because the metal was fairly soft, and I simply used a 6mm drill bit just to drill these out. So it was literally a 2-minute job, because sometimes these spacers, they can be made of steel or stainless, and it's a bit of a nightmare to drill them out, but it's not a drama. So they actually drill out quite easily. Don't need to use Dremels or anything like that, just use a 6mm drill bit and drill them out quite easy. So I have put everything back together again, and I just want to show you, if I can just zoom in, just grab a screwdriver quickly. So these are the plastic screws that I've used, and they are 3mm, about 15mm long, I mean, you can buy these relatively easy online. They're as cheap as chips, and they usually come with the associated plastic nut. And the other thing I've used as well, I don't think you'll be able to see it so easy. Yeah, possibly. So underneath the board, keeping the board off the chassis, I've used some 5mm plastic spacers, which are also M3. And it's not that difficult actually. I thought it would be a bit of a fiddle, but it's quite easy to do, to get the board back in again. And last time I tried this, I got a very warm connecting lead. So what we'll do, we've got them connected up. Let's switch on now and see if we can get 28 volts. So let's go for it. Not getting any funny noises. 28.51. That is just what we want for the Collins 618T. And obviously, if you're in the market for a 28 volt power supply, which if you've got a lot of vintage, or actually for that matter modern aviation gear, aircraft gear, most of that runs off 28 volts. So wiring these two servers together in series, and it is possible, it can be done, providing you float the one supply, because obviously the negative of this one isn't floated, and that will be going to ground, but this one is floated. You have to make sure you get the order right, because obviously you can't have this one, you can't have the output of that grounded, because that's going to theoretically cause problems, because your negative on, if you swap them around, the negative on that one's not grounded. So you have to get them connected in the right way. So it goes negative. Okay, the non-floated power supply, it's going to go negative, positive, positive, negative, positive, negative, positive. So you have to make sure you get them in the right order for this whole thing to work. And so once I've put all these back together, I'm going to obviously scribble on the chassis that this one here on the right is a floated unit, and so therefore we can use it in series. One of the things that I didn't mention at the start of the video, but you might have already seen it, is that in order to get these power supplies to work, you do have to connect a couple of pins together. You have to shorten them out. Some people put like a 1K resistor, but it's not necessary. You just need to place a wire across the pin on the end, which I think is 33, I think it's marked that, and then you just simply connect it to the 1, 2, 3, fourth one along, which is actually the shorter one. You can tell it's the right one because it's the short. It's slightly shorter than the others. Anyhow, just to prove that this does actually work under load, I'm going to turn it on. I've got a 200-watt light bulb on this, and as you can see, it is pretty bright. That's 28 volts at 200-watt light bulb, aircraft bulb actually. So there you go, it does actually work under load, which is what we want. Just turn it off again. So I'm quite happy with that, it does seem to work. So there we are, chaps, that's it. I hope you enjoyed that, a quick video on how to modify these server power supplies, and there's plenty of them if you need one, and they're not very expensive. Thanks for watching, and catch you all again soon.